Yeah, and before talking about what's new, I think I want to pick up on a discussion that came up yesterday in the presentation that Greg gave, and talk about the stuff that's old. And that's about answering the question regarding how to do versioning of workflows and how to figure out what's different between different types of workflows, the same workflow, different versions, etc. And what I've prepared here, also after I saw Arne's presentation, I needed to install those exo processing extensions. So this is KNIME, by the way. I keep doing the same joke over and over again, and people laugh, so thank you. Okay, so here I have one of those workflows that I took from the Community Hub. It's one of the workflows that Arne presented. I wanted to poke around, change it, but before doing that, I made a copy of myself and then I changed it. I ended up with two different workflows, same name, just the number 2, number 3, etc. And knowing what's different between them, there's this compare feature in KNIME. It's available in the open source. You just compare the two workflows, and what it brings up here is this, this list. So each column represents one of the workflows that you'd like to compare with all the nodes. They have many, many nodes in common. You can hide the nodes that are the same, and what remains now are the nodes that are different or added, removed, etc. And now you see, for instance, that node is present in one workflow but not the other. And you can also select individual nodes and make a diff of their configuration. And then you see, for instance, that has changed. Or for a rule engine node, you see that's a bit more advanced, where you see that's the field that's changed. You can also see there's, for instance, this node number 8. Number 8. There's a trick here. You see this is rule engine number 8, and this line has changed. So that's what we understand as diffing of workflow, which is currently available in KNIME Analytics platform. But now the new pieces. I took one of Thomas' slides here, just presenting our software portfolio. I'm not going to talk about server or partner extensions, but instead I just talk about the top left part, which is KNIME Analytics platform, and the extensions and integrations that we have in KNIME. I was briefly thinking about having some sort of agenda, but it would just be a number of list of different changes that we've made, so I just stop right in and list them out here. The one piece that I'm not going to demo, but that is certainly worth mentioning, and I just had this morning a nice conversation with Gerhard Schauer about the database integration that's available in KNIME. This is what the current version of the database integration in KNIME looks like. It's such a workflow. You have different connectors in this case, and then you do some database processing like row filtering, column filtering, grouping, querying, etc. So these workflows usually have these red-ish ports, and they essentially combine a SQL statement or compose a SQL statement that you then eventually can execute, and then what falls out is a KNIME table that you can further process in KNIME. That's nice. What we've done is we've kind of rewrote most of that part, and that is now available in KNIME Labs. It's, so everyone should already have that because it's already available in 3.7. There were some changes that are under the hood, and each of these things also came up this morning in my discussion with Gerhard. The improvements that we've made is in case you have different schemas in your database. This was kind of glitchy in the old extension. This has much improved. Flexible type handling. There was this one question about date and time handling and problems that kind of challenges that he had using it in the existing database nodes. That's much improved. There is some sort of type mapping that allows you to retain types from your database and bring them into KNIME. And in case you have to write SQL statements, then there's now also a rich syntax text rich editor that has all the drop-downs and allows you to compose your SQL statements very easily. But most of those nodes are very simple to use. They have for instance, the column filter has the left, right, the twin list that people are used to. From the more on the back-end side, what has changed is there is further improved driver handling, so you can have different versions of drivers that support different dialects of the database language. There is a notion of parallel execution or concurrent connections to your database, which is extremely helpful if you run this on KNIME server, and they now also start to support streaming execution. The other topic I'd like to cover is KNIME's big data extension. So the big data extension is really two parts. Those are big data connectors, that is essentially big data databases that integrate with the database nodes that I've just shown, and the KNIME extension for Apache Spark. So Spark is this execution framework that sits on top of Hadoop and allows you to build quite complex queries and massage and do something with your data that lives in a cluster. And KNIME's integration looks like the one here at the bottom. In this case, the ports are not red but black, and there are different nodes that allow you to do some compose a Spark query. There's also a machine learning integration available based on MLlib. So for instance, in this case, there's a decision tree learner and a predictor, the typical pattern that you also find in KNIME. So the nodes, they adhere the same usage pattern as standard KNIME nodes. The changes I'd like to point out is on the backend side, we use a different framework to communicate with the cluster that's based on Apache Livy. If you're an end user, you couldn't care less, but if you are kind of the admin of your cluster, you will like that a lot. That's kind of industry standard. This is how you talk to the cluster. One of the added benefits is that we now also support PySpark, which is also a fairly frequently requested feature for the big data extensions. I'd like to, maybe I can also mention that briefly, because that is somehow related. So we added like more than a year ago an integration with H2O. H2O is a fairly popular machine learning library. It's also part of the same Magic Quadrant that we are in. Some people say it's competition, but everyone who knows H2O and KNIME will say it's not. It's more some technology that complement each other very nicely. So H2O has this nice set of highly optimized, highly scalable machine learning algorithms for learning predictive models like boosted trees, tree learners, linear models, and so on. There's a bunch of nodes. They're all listed out here. And these workflows, they usually look like this. They have what's called an H2O context node that kind of starts your H2O workflow, and then you have to convert your data into this H2O data frame, and then you combine different H2O nodes, build a model, do some data manipulation, etc., and then you have your result. The change that we made in last year was an integration with H2O Sparkling Water. Sparkling Water allows you to run H2O workflows in Apache Spark. So the difference here to the workflow is very minimal. So instead of having the H2O local context, there's a Sparkling Water context. Once you execute it, this piece will run in your cluster. You can run this on larger data, but otherwise the workflow is exactly the same as the local version. Okay. Before going into deep learning, I'd like to do a very brief demo and introduce you to one workflow that I'm going to use later also. It's this workflow. That's the typical usage pattern. You read some data. In this case, it's some adult data. Don't look too much at it's adult data. It sounds weird, but it's a data set that describes different personas, and there are some descriptive fields, and there is some output field. Okay, so that's a typical pattern. You have your data set, you partition your data, you learn a model. In this case, a gradient boosted trees, that is a native KNIME node. You apply your model, you do some scoring. You can bring up a visualization that is, in this case, a rock curve. That's all data science topics. I'm going to continue the same example and do this in different frameworks. And before, this is a reminder for myself. I'm not going to talk about the technical, the algorithm itself and what tuning parameters there are, but I'd like to point you to Dean's workshops on Friday, where he's going to talk about everything that relates to trees and how to use them in KNIME. What I'd like to do instead is just show you how the same workflow could look like on different platforms. Not because it's necessarily sensible, but just to show you the options that you can do in KNIME, and it always depends on your application where you run those type of things. So the same thing in Apache Spark would look like this, very similar. You had your data here in Spark. You would need to do some more pre-processing because the libraries that are available in Spark are not as powerful as you find in other frameworks. You build your model, you do a prediction, you do some scoring. This node, by the way, it's called Create Local Big Data Environment, is also one of the new additions in one of the previous releases. It allows you to build Spark jobs and run Spark jobs locally on your laptop. So I'm not connected to a real Spark cluster here, but it helps me to design those Spark jobs locally, and then in case I really want to go big, I would need to use a different connector here. So I should be able to run this fairly quickly, and this will build a model, etc. Not going to look at the model or model statistics. Obviously, this fails now. I'm not going to diagnose a problem here now. The same thing in H2O would roughly look like this. Again, it's the same problem, just using H2O here. So I told you about the H2O local context, how to get the same data set into H2O, and then performing your analysis and building a boosted tree here. The one thing I'd like to point out is that these nodes, the configuration diagrams of these nodes look fairly similar, but there are still some differences in terms of what knobs you can tweak. So if you compare this to the gradient boosted trees learner up here, this has the same main panel, but the configuration options, they change slightly. And the same piece, this is now running locally. If I wanted to run this on Spark, I would use something like this down here, where I had where I was using a real cluster here, so I had a Spark context node that connects to the remote cluster side, in this case in Amazon, and then I can run this doing the same analysis. So this part of the workflow is exactly the same. I'm going to use this workflow in a second. Before doing that, I'd like to talk a bit about deep learning and the deep learning integrations. By the way, I'm talking about all the new stuff and machine learning or deep learning and AI, etc., because this is what we'd like to talk about. There are also other useful extensions that are probably more relevant to most of you, because I would think that deep learning is not what everyone does. I'm going to come to that in a second. Deep learning. So what we do as KNIME, in KNIME, we are not a deep learning vendor per se, so we don't invent new deep learning algorithms. What we do instead is we make available what is available mostly in the open source world, and integrate that into KNIME so that's usable by non-experts of deep learning. We used to have a Keras integration already with 3.5, so that came out the year before last year. Last year we added the TensorFlow integration. That's what such a workflow looks like here. In this case, you can bet from the name of, or guess from the name of the node. It's doing some image analysis workflow. It's reading some pre-trained network that was available that, for instance, a colleague gave me. It's reading this network, and then you can apply this network, this pre-trained network on my data set, and then for instance, do some scoring and do some image classification in this case. This was available already in 3.5. The thing that we added recently was a bunch of nodes that allow you to compose your deep learning network. And those are all the nodes that you find up here on the top. They are different. No, okay, this is hard to read here, I guess. There are different nodes. Keras input layer that kicks off your workflow, convolutional layer nodes, more nodes, max pooling, 2D layer, dropout layer. Honestly, I don't know what all these nodes do. There are in total more than 60 of those nodes. And since we have time, I can read through all the node descriptions now. No. These nodes allow you to build the network, and then you have, in the end, you have your executor node that then learns the actual parameters of your network based on your input data. There's also some graph that shows you how the learning is going on. There's also some early stopping. So if there's a button that allows you to stop the learning because learning tends to take long. And the other thing we added was a TensorFlow integration. So TensorFlow is a deep learning framework that came out of Google. Again, they have a bunch of networks that are available from Google. You can use them and read them in the TensorFlow network reader node. Another node that was added is a converter node that allows you to take a Keras network, convert it into TensorFlow. The reason why you would want to do it is that the execution of that network tends to be much faster because TensorFlow, there's a native integration and the execution is faster. There are more nodes that allow you to manipulate networks, etc., but I'm not going to go into details here. Yeah. Again, if you are interested in deep learning and how to do those type of workflows, create workflows, and what all these 60 nodes do, there will be another workshop on Friday given by people from KNIME. Adrian and Christian are going to talk about that one. Okay, now more leaving all the data analytics aside, talking more about other noteworthy integrations that we added into KNIME and that are available in 3.7, 3.6. The first one I'd like to start with is our integration with Google services. So KNIME had integrations with Google Analytics and Google Sheets previously. The one node that we added is a Google Drive connector. So in case you have your data or part of your data in Google Drive, you can now use it seamlessly in KNIME. It's one of those nodes that integrates with a file handling extension in KNIME. Yeah, it's based on the same type of authenticator. So this piece here, once you execute it in the configuration dialog, it requires you to enter your Google credentials. Once you're authenticated, then you can use all these, the Drive connector, Google Sheets nodes, and Google Analytics, all with the same source node. This one, important, this one is for everyone who's doing just basic data manipulation. Column expression node. It's kind of our Swiss Army knife for data preprocessing. It's kind of for you who are used to design KNIME workflows. It's kind of a mixture of rule engine node, string manipulation, math formula, and also to some extent Java snippet. It has complete type support. It allows you to design, create multiple outputs here. So the table here at the top allows you to define all the fields you'd like to add or change, or columns. In KNIME we call that columns. And the piece here at the bottom tends to be much simpler. It's usually a single line and looks like what is done in math formula or string manipulation. But if you like to, you can also write very simple scripts. Try, please. Integration with Tableau. Any Tableau users here? No? Okay, integration with Tableau. We used to have, and we still have an integration with Tableau based on their format, which is called TDE. The one addition we made is supporting Hyper, which is their future kind of file format. In KNIME, we have nodes that allow you to convert a table into this hyperformat and store it locally, or the other node that's available is called send to Tableau server, that takes that extract and push it to a Tableau server where you have your report set up, and it will just display and update your report on the new data. What I often see is that people do is they use KNIME for data processing and dealing with large data, and then having a condensed, aggregated snapshot of the data, and then they display that in Tableau. I guess that is also the case for most of you. I'm sorry, this is also again about machine learning and building models. An integration with XGBoost. XGBoost is a very popular library, so if you are a Kaggle competition person, you must have heard of XGBoost. It's a very popular library for distributed gradient boosting. They are best known for their implementation of boosted machines. If you look at their configuration dialog, you have an idea why that is, because there's so many parameters that you can tune. It's, as I said, it's often used in machine learning competitions. And I think this one, also important, called workflow automation. Greg showed that yesterday in his session on deployment of workflows. He introduced you to the concept of container input nodes that's based on tables or a bunch of variables. There is now also a node that allows you to just pass in a single row or record into your workflow, and then you do something with all the data. And this is very complicated. It does column filtering. And then the result is put out into the container output node. So these greenish nodes define sort of the input API of your workflow, and the one here on the right-hand side is your output. And these workflows can then be deployed on the KNIME server, but I'm not going to talk about KNIME server here. But you can also use them in your in other workflows. So you can build a whole set of workflows that call out to each other. The model factory that was presented in previous year is based on the same concept. So you have one master workflow and instrument the whole set of other workflows and call out to them. And depending on switches and runtime data, you call out to different workflows. I'm going to show that in a second. The other thing, but I'm going to show this one, is an integration with Jupyter notebooks. So let me go back into KNIME quickly. The same workflow here, there's one more that I need to scroll. When I scroll down to the bottom, is that integration with XGBoost, same pattern, same learning and prediction. Now what I did with that workflow, I split it up into this workflow, which looks very much like the one that was shown here on the slide before. So there's a container input table node, there's a configuration dialog. So that's kind of the template data that I use to design my workflow. And this data set, it's a small data set, is now saved as part of the workflow. And these wrapped meta nodes, they have these different implementation of the boosted machine, and I'd like to do some comparison just to figure out what these things do. So if I go in here, it's the same workflow, partitioning, and then prediction, learning and prediction. I'm doing the partitioning here in each of these meta nodes. If you are a data scientist, you would say, you should do this before this. We don't care about these little details here. There's the other one for XGBoost integration, and the third one, which is doing this using H2O. So if I take this workflow here, there's my caller workflow. This is the call workflow table-based node. This is now having, it has the same data set, just a bit larger. And this is now pointed to this workflow that lives relative to the workflow that I want to call. So it's just one level up, and it's that name. You can do some assignments of inputs and outputs, so tables. If I reset this one and execute it, what will happen with that other workflow? It's now executing. Dun, dun, dun. And then I can look here at the output. So that's model comparison. Make this a bit larger. So here we have the area under the curve for these different algorithms. Yeah. When I prepared this demo, I also noticed, okay, here there's KNIME, there's XGBoost, there's HDO, and KNIME performs worse in this case than the other two. And I sent an email to Adrian and say, this is going to be a demo, we shouldn't do it like this. And he was in a session on Monday, and he, like 10 minutes later, he sent me an updated workflow with parameters slightly tuned. I think the tree level is what he changed and made them all equal. And KNIME turned out to be the best one then. And I said, nah. Too easy. Okay, the other thing, the other integration, the other nice add-on that is available for KNIME, not in KNIME, but for KNIME, is an integration with Jupyter notebooks. Any Jupyter Python fans in here? Okay, so there's an integration now also available in Jupyter that allows you to call out to KNIME. So you have a KNIME workflow. I have to prepare my workflow because these are going to be used here. That's a Jupyter notebook, does some imports, and there's also this import line, which is a KNIME library that is available from PyPy, and I can just run through those. So there's some more configuration set up here, like where does KNIME live, what's the workflow that I'd like to call out to, etc. And this is the first important line where I call a method just to load the workflow. And what it does, it loads the workflow and displays an image. So I have an idea of what I'm going to call out to. It's the same workflow that I've just shown, the input and the output data. If I continue this one here, I read the file and do some more stuff. This is going to now execute the workflow. It pops up something, go back here. This is now going to execute the workflow that I've shown you based on that input data. This will take a second. You see that by the little star. Time for a question or a joke. No questions, a joke, no. Still takes a bit. If I go to KNIME now, this one is blocked because it's been executed by a different process. So I'm not able to open this workflow here. Still takes a bit. Okay. Almost there. Now it's done. I can step further. I executed the same line. Okay, I'm sorry. What this is going to show me is the same result. So I'm going to get the same table, the same, in this case, the same data frame that I've shown you previously with all the different scores that were computed by the workflow up above here. And then obviously I can use that further in my notebook or also use it just in a plain KNIME script. Okay, while this is ongoing, I'm glad that Greg yesterday had a session on deployment, and he showed you all the stuff that was added to in the realm of visualization and guided analytics. So he talked about heat maps. He showed that in a demo, so I can happily skip that, the hierarchical cluster assigner or the tile view, and also the layout editor that allow you to design nice layouts of your visualizations. Okay. This sort of wraps up this part of the session. I have one more thing to do, because that's what we used to do. We always split this session between what's new, what was added in the previous two releases, and what's cooking. What's cooking this time is a bit shorter. We continue to work on utility nodes and small add-ons to KNIME. One big theme is still the continued integration of all these database nodes, obviously. On the big data side, there is a new framework that allows you to do Kerberos authentication for various different nodes, database nodes, Spark nodes, and it will be a general framework. There will be more nodes and extensions coming, all in the kind of in the context of automation, guided automation, nodes for model interpretability, different feature selection strategies that tend to execute faster, like just random search genetic algorithms. And there's one more thing that I'd like to show. Let's see if this is done. Yeah, this is now done. One more thing I'd like to show is a comparison between 3.7 and 3.8. So those are two different KNIME windows. Before you get eye cancer here. Oops. Those are the same workflow, just opened in two different KNIME workflows. This is 3.7, this is 3.8, which is a nightly version. It's not yet available. It will be available sometime in summer. And this reads a data set that's fairly large. It's not huge. It's not small. It's large. It's 100,000 rows and 100 columns. It's something like 80 megabytes on disk in a compressed form. If I run, and then the workflow is just some sorting, manipulation, joining, etc. And I'm going to execute this now. And please watch out now. I click the screen button up here. I click it down here. And you will notice that the workflow in 3.8 tends to execute much faster. Okay, while this is executing, I go. I didn't do it. I didn't do it. It was a team. It was a team. Yeah. Why is that? So the execution tends to be much faster. There are different parameters that we changed. There will be, or there is already available, a different data storage format based on Apache Parquet that we use, that you can use in the back instead of the native KNIME format that also supports all the editions. There are different compression schemes available for the data that we then save on this in case we have to save to this. The 3.8 will use much more aggressively the main memory that you assign it to that you assign to KNIME. There will be less aggressive logging, so the log files tend to be smaller, which is also influencing execution time, and there were other changes that were made. That is already available in a nightly build. Again, nightly builds are available. Just want to Google KNIME nightly. It will bring you on to this page where you can download nightly builds, and you can try this with your workflows. And with that, I'd like to wrap up here, and thank you.